In this pre-calculus algebra video, we will look at polynomial and rational inequalities. To start with, when we have an inequality, actually I forgot about this problem. At the end of this section, we're going to be able to apply the concepts of polynomial and rational inequalities, how to solve them, how to get a solution set for a polynomial inequality or a rational inequality, to explore different stopping distances that are required when you're driving compared to driving on wet pavement and dry pavement. You'll find that problem in your textbook, the end of the section. To be able to do that problem, you need to be able to solve a polynomial inequality. Here's how you solve a polynomial inequality. The first step is to set this to 0. You see that we have a minus 3 here. So we're going to do a plus 3. We're going to add 3 to both sides so that we can set this to 0. That would give us 4x squared plus 7x plus 3 is less than 0. The next step is going to be to factor this. To factor 4x squared plus 7x plus 3, I'm going to multiply 4 and 3 to get 12 and keep the 7. Now the reason that I'm factoring this is that I'm trying to solve the related equation. The related equation would be 4x squared plus 7x plus 3 equals 0. The equation we have, or the inequality we have, is that the polynomial is less than 0, but the related equation would just change that inequality to an equal. When we solve this related equation, we would get a 3 and a 4. And so do you remember what to do with that? That says that we break the 7x into a 3x plus 4x. It would look like this. You could put it in either order. But we break that 7x up to 4x plus 3x. That's what we do with this chart when we solve it, because 3 times 4 equals 12, 3 plus 4 equals 7. And now what we can do is factor by grouping. So I could divide out 4x from the first two terms, divide out 3 from the last two terms. So we'd have 4x times 4x squared divided by 4x is x. 4x divided by 4x is 1. So we'd have 4x times the quantity of x plus 1 plus 3x times the quantity of 3x divided by 3 is x. 3 divided by 3 is 1. So x plus 1. And when I pull out the common x plus 1, the remaining factor is the 4x plus 3x. And once I have this factored, I can solve the equation by setting each of the two factors to 0. So for x plus 1 equal to 0, I'll subtract 1 from both sides and get x equals negative 1. For 4x plus 3x equals 0, I'm sorry, I wrote 3x. I said 3, but then I wrote 3x. Let me highlight that so you can see that. This number here should have been a 3, right? So we'll get rid of that x there. So we have 4x plus 3 equal to 0. And when I set 4x plus 3 to 0, I can solve that by subtracting 3 from both sides. And then I get 4x equals negative 3. Dividing both sides by 4, we'd get x equals negative 3 fourths. So we have, for our related equation, two solutions. X equals negative 1, x equals negative 3 fourths. What we're going to do with those solutions is put them on a number line. Now be careful with this negative 3 fourths. It's so close to that negative 1. We don't have to have equal increments here, but make sure you put these in the right order. So if I had a 0 over here, this negative 3/4 would come before the negative 1. And what I'm going to need to do is find a test value in between each of these intervals. It could be any number I want, something to the left of negative 1, negative 100, or negative 10. This is a tricky one. I need to find something between negative 3/4 and negative 1. So what if I use that negative 3/4 is the same as negative 6/8, and negative 1 is negative 8/8. Then I could find this test point, negative 7/8. It's not really easy, but you can find a number that lies between negative 1 and 3/4. And then the 0 is always a good number to use as a test point. Here's what that would look like on our number line. We have our negative 1 and our negative 3/4 and our 3 test points. What I'm going to do with those test points is plug in the test point, the negative 10, into this inequality, not the related equation, but the inequality, and see if this is true. Do you notice that what I'm looking for is whether or not the two factors multiplied together are less than 0 or not? Or in other words, I'm just looking for, is it positive or is it negative? It doesn't matter what the exact value is. We're just looking for, are we getting something that's positive or negative? If you recall multiplying positive and negative numbers, so multiplying integers, if we multiply two negatives, the product comes out positive. If we multiply two positives, product comes out positive. The only way to get a negative, so to get something less than 0, is if one value is negative and one is positive. So when we put our test point in, when we let x equal negative 10, we'd have 4 times negative 10 plus 3 comes to negative 37. Negative 10 plus 1 comes to negative 9. The exact values don't matter. All that really matters is that it's negative and negative. So when I multiply those, I get a positive. So this does not solve this inequality. It's not less than 0. Or in other words, it's not a negative. When I let x equal negative 7/8, I get a negative and a positive. So when I multiply those, I do get a less than 0. So this segment from negative 1 to negative 3/4 does solve that inequality. And then when x is 0 or anything to the right of negative 3/4, we get positive values only. When we multiply those, we get a positive. So our solution to this in interval notation is going to be from negative 1 up to negative 3/4. Anything in this interval, because that test point, negative 7/8, made this statement true, made the inequality true, any number in that interval from negative 1 up to negative 3/4 will make it true. Now, did you notice those parentheses? I didn't put a bracket on that negative 1 because we have a less than, not a less than or equal to. If it had been or equal to 0, then the negative 1 would have made it equal to 0, and we would have included the negative 1. But since it's just less than 0, we have parentheses instead. Let's try another example. Here's an example with a rational inequality. So once again, we're going to set this inequality to 0. So I'm going to subtract 2 from both sides. Now, this is where it gets a little tricky. We have to review some work with rational expressions to be able to do this. It would look like this. If I had x plus 1 over x plus 3, and I'm going to subtract 2. If I want to simplify this now, because I need to combine these two pieces, I'm going to need a common denominator. And so this x plus 3, I need to write the minus 2 as something with an x plus 3 as a denominator. So now I have x plus 1 minus 2x plus 6 all over x plus 3. So it would look like this. Our x plus 3 is in the denominator. We're less than 0. And then we would have x plus 1 minus 2x plus 6. But did you see what I just did with this plus 3? It's the most common mistake to make as students do this problem. I hope you caught that negative actually needs to distribute. So it's the opposite of 2x. There's our negative 2x. And then we also need to distribute it to this 6. So we're going to make the 6 negative 6. Do you see why the negative 2 times x is negative 2x? And negative 2 times 3 is negative 6. Next, I'm going to combine these like terms. So an x minus 2x would be the opposite of x. And then 1 minus 6 is negative 5. So I have the opposite of x minus 5 over x plus 3 is less than 0. And that's it. We've solved this for 0. We've set it equal. We've set it to 0. The next step is going to be to find the critical numbers. For a rational expression, the critical numbers are the numbers that make this equal to 0 or undefined. So in other words, what would make the numerator 0? Negative x minus 5 equal to 0. So the opposite of x is 5. X is the opposite of 5. X equals the opposite of 5 is a critical number. And then what would make the denominator, the x plus 3, 0? X plus 3 is 0 when x is negative 3. So those are our two critical numbers. We're going to proceed in the same way we proceeded with a polynomial inequality by graphing each of these on the number line and finding test values in the intervals. So let's look at what that number line would look like. We would put our two critical numbers, the negative 5 and the negative 3, on the number line. And because this inequality is less than, not or equal to, I'm going to have a broken line drawn down from both the negative 5 and the negative 3. And then I'm going to evaluate this, the opposite of x minus 5 over x plus 3 for each of our test points. I'm going to let x equal negative 10 and see if I end up with positive or negative. When x is negative 10, we have the opposite of negative 10 is positive 10. 10 minus 5 is positive. And then negative 10 plus 3 is negative. So what does that turn out to give us? It gives us a negative value. And since we're looking for negatives, it looks like this is included in our solution set. When x is negative 4, we have the opposite of negative 4 is positive 4. 4 minus 5 is negative. Negative 4 plus 3 is negative. So a negative divided by negative is positive. This is not in our solution set because we're looking for values that are negative. And this was positive. And then when x is 0, 0 minus 5 is negative. 0 plus 3 is positive. So we'd have a negative divided by a positive, a negative. So it looks like this part is in the solution set also. So it looks like the solution will be from negative infinity up to negative 5, or from negative 3 up to positive infinity. And that's our solution. Let's try one last example here. We've got an application problem that we're going to solve using an inequality. when we look at this application, what we have here is the question is during which time period is the ball's height higher than the rooftop? So if we have S of t, negative 16t squared plus 48t plus 160, is modeling the height of the ball, and 160 is the height of the rooftop, we have that here, then what we're looking for is when is S of t greater than 160. What we're going to do next is find the related equation and set it to 0. So if we subtract 160 from both sides and write the related equation, we'd get that the related equation is negative 16t squared plus 48t is equal to 0. So subtract 160 from both sides, and that's greater than 0, but then the related equation would be equal to 0. We could solve that equation by factoring. I factored out the GCF, negative 16t, and the other factor is going to be t minus 3, so that gives us t equal to 0 or t equals 3, and that gives us our chart. What we'll want to do next is find test points in each of these 3 intervals, because we want to see in which of these intervals is the ball's height greater than the 160. The test points I'm going to choose are negative 10, 1, and 10. So if t is negative 10, we have negative 16 times negative 10, that's a positive, and then we have a negative 10 minus 3, which is negative. So over here we're negative. We're looking for values that are positive. So this interval doesn't work. Let's test a 1. When t equals 1, we've got negative 16 is negative, and then 1 minus 3 is negative. So when I multiply negative times negative, that comes out positive. So it looks like this interval is good. And then the last interval, when I use a test point 10, if t equals 10, negative 16 times 10 is negative, 10 minus 3 is positive, a negative times a positive is negative, so it looks like this is not positive either. So the only interval that works is this interval from 0 to 3. Now be really careful that we're not going to include the 0 or the 3. And let's look at why. So it's the solution is, when is the ball's height exceeding the rooftop? It's between 0 and 3 seconds. If I put that in interval notation, it would look like this: parenthesis 0, 3, parenthesis. Do you see why it's not equal to? We're not equal to 0 because with the 0, that would give us, a 0 would give us or equal to. When t equals 0, the function is greater or equal to 0, and that's not included here. We're only looking for the values where the negative 16t squared plus 48t exceeds or is greater than 0. So there is our solution between 0 and 3 seconds. I hope you'll keep working on applications like this and inequalities that are polynomial or rational. The more you practice it, the easier they'll become.